Hello, everybody. I will start my today another live coding session. So today I solved this question: regular expression matching. Okay. So I actually solved this question yesterday. I was, you know, I turned on the camera and I was shooting the video, and it took about an hour, and I couldn't solve it. So I solved the video and I solved this question, and in total it took 2 hours to solve this question. So basically, I would say I tried to solve this question in 2 pointers first and took an hour, but it didn't work. So I I solved this question with the regular dynamic programming, and in that way I could solve this question, taking an hour. So today I will go quick because I already knows the answer of this question and solution. Yeah. So let me get started. So in this question, I'm giving a name to string S and a pattern P. Implement regular expression matching with support for period and asterisk, where period matches any single character and asterisk matches 0 or more of the preceding element. The matching should cover the entire input string, not partial. Okay. So let me clarify my understanding first. So in this question, the input should be the string S. Oh. And also I will be given the P, which is a pattern, which should be also the string. And I will return Boolean, which represent if given string S matches the regex expression pattern P. If it is true, always return true. Okay. So let me check the constraint. So as it's written in this constraint, I can find S contains only lowercase English letters. So S is A to Z. Yep. For P, it contains lowercase English letters A to Z and period or asterisk. It looks like this. Yeah. Okay. So this is a constraint. And also, as I can find here, ranks of the S and ranks of the T is quite small, up to 20. So actually, that's why I could use the dynamic programming for this question. First, I tried to solve this question with 2 pointers in O of S plus P, S ranks and P ranks, but it didn't work. But because these two numbers are small, relatively small, I can use the dynamic programming in this question. Anyway, let me take a look at the examples. So let's say S is ABC and P is ABC. In this case, I should return true. Good. Maybe this is too simple. So P can be something like this. Obviously, in this case, I return true. And in this case, this suggests A is, repeated 0 or once or twice or 3 times or any times. So A, B, C, and A asterisk C, they didn't match. But if this is this, it matches, or this matches, this matches. Okay. So I think this is a bit complicated. So let me check it. Oh, sorry, let me write it down. So for this case, as I said, this should return true. This case, I should return false. And I can say if pattern is A sharp C, then it matches C or AC, AAC, AACC. Yeah, all of these matches. Okay. So aside from that, what I can say is, yeah, actually, with this one, round 22, I missed this when I solved this question yesterday. I have to take care of this. Yeah. As I said, A asterisk can signify empty substring. In that case, just C matches H asterisk C. And one more thing I missed, or I should say I misunderstood when I solved this question before, was this one. Actually, this matches. Because this suggests, I mean, this is equivalent to this or this or this or yeah. So this actually can represent, or just say this matches any string, yeah, including the empty string, because this can be any character, and I can repeat any number of times I want. So it's okay that I repeat only 0 times. In that case, it should be an empty string. And if I choose A first, as I've written here, this doesn't mean I have to repeat the character I choose for period. This is equivalent to this or this or this. And for each period, I can choose any character. So A is fine, A, B, C, D is fine, A, D, D is fine. Yeah. Empty string is fine. Okay. So this is a bit tricky again. Yeah. So I have to take care of this. Okay. So now what I can say is, let me, quickly summarize what kind of patterns there are. So this is the case when no asterisk or period. Or I can say there is a, yeah. So in this case, period is included. And in this case, asterisk is included. And also I have the case that it has both of asterisk and period. Yeah, like this. Yeah. In this case, it's okay. Or maybe it can be something like this. And as I said, this pattern is more tricky. Yeah. So I have to take care of this. As I said, this can match A or AA or AAA or ABC or ABD or AXY. Yeah. But in this case, it matches empty, A0 times and any single character like ABCDE, or A once and any character like AB, AC, AD, or A twice and single character like AA, B, AAC. Yeah, or maybe many more number of times for A. And then single digit on an additional character. Yeah. That being said, I will take care of this. And one more thing I forgot to mention is, as it's written here in the constraint, there will be a previous valid character to match. So this is possible, but I can say asterisk never begins itself. Yeah. Or let's say a asterisk asterisk. In that case, a is repeated any number of times with a asterisk. And for the second asterisk, I don't have the character to be repeated. So this is not allowed. Yeah. Same for something like this. Aside from that, yeah, there isn't anything which is not given as the pattern P. Okay. Yeah, anyway, I'd like to say that every time I have the asterisk, it has something before, maybe a dot or sorry, a asterisk or period asterisk. Period asterisk case, yeah, in this case, as I said, I can choose any character and I can repeat or, continue any number of times, like AB, ABC. Okay, that being said, let me think of the algorithm. So as I've mentioned in the beginning of this video, I solved this question with dynamic programming yesterday. So 2 pointers, it didn't work for me, but top-down DP worked. So I don't pretend that I'm struggling here. I will immediately start using the top-down DP. So I will tell you the algorithm. So let's say I'm comparing this and this. Okay, wait a minute. Okay, in this case, this actually matches. A and A matches, B and period matches, C and C matches, D and X doesn't match, but X has asterisk, which suggests I can repeat any number of times for this X. So I choose to repeat 0 times, which means that X is completely ignored. In that case, I can skip this X asterisk, and then I compare D and D, which matches. So I should return true. So that being said, the interface of the dynamic programming recursive function looks like this. This is S index and P index. Yeah. So I'm given SI and PI as the argument of the recursive function. And I will compare substring, which begins from SI in string S, and substring in P, which begins from index PI. And if they match, I return true. If they don't match, I return false. And I memorize this result in the cache because let's say I find the result from index, SIPI is index 22. In that case, maybe I come again. I call this matches method again. Let's say match. Yeah. Maybe I call this match method again with the same argument. In that case, obviously I don't have to do the recursion again for this. Yeah. I can just remember false or maybe true. Yeah. But probably if the case of true, Yeah. Yeah. In the end, it should be possible. Sorry, maybe I'm explaining something I don't have to explain, and it's a bit difficult to, explain. But let's say if I call true, 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 and false, yeah, in that case, no. If I find false, it should go up to false. Yeah. So please just forget what I was saying. I actually don't explain something I don't have to. So anyway, I returned the boolean and also memorized it as a cache. Okay. And the problem is how I can compare substring from index si and substring from index pi. So here I will think of the logic inside of the recursion. So I think I have a few cases. And definitely the tricky thing is something like this. A asterisk and I compare CAA. In this case, it seems like C is not A, but because I have the asterisk next, it's okay that I can completely ignore this A asterisk. I have to take care of that. So to take care of this, I think the intuitively easiest way is if I have the asterisk as the second character, I treat this first char and asterisk as a single chunk, and then I compare this with string, prefix of si. So if this is a, it's possible that I match until this, or maybe this, or maybe this, and the third one. It depends. But let's say I have a asterisk ac. In that case, I want to match this a asterisk until the second a, not until the last third a. Yeah. But I actually don't know which, until which a this a asterisk should match. So I will try each case and call the recursive function from each case and check the result. Yeah. So that's about a asterisk. Yeah. Aside from this, there's a case that I have P begins from asterisk. In this case, I think this is quite simple. I just have to ignore the first character A and move Si and Pi, each of them, by one index forward. So this is quite simple. Yeah. And after moving it, I compare the result from here to here. Substring of S and substring of P, and if they match, it should return true. Yeah. So moving forward, moving the pointers forward means that they match until that. Otherwise, I return false from this recursive function. Or I have something like the very, exact character A or something like this. Yeah. For example, in this case, obviously, if SI character and PI character matches, I move both of them. Or if they're not the same, I return false. Okay. One more thing. I said about A asterisk or maybe B asterisk or C asterisk case here, but also there is a case that it has period asterisk. Again, in this case, this comma asterisk can mean, length 0, empty character. In that case, I move pi only and check if they match. The child result. If it's true, I return true from the parent recursive function method. Or this can match under here. In that case, I continue Si from B, or maybe until here. In that case, I continue from C. Maybe until here. In that case, I continue from Si. Is equal to D, factor D. So I compare, I retry each of these. Each means that until which character this period asterisk matches. And for each, I call the recursive function and check the continuous result. Yeah. And if any of them is true, I return true from this match method. Okay. Good. That being said, let me get started the implementation. Oh no, I do the complex analysis. For time complexity, as I can see here, match method has Si and Pi argument. So the combination of these arguments should be length of S times length of P. And for each, it takes basically the constant time. Because I choose, no, not the constant time. So for line 73 and line 74, it takes only the constant time and calls the next recursive function. But for line 71 and 72, it has to take a look at max S characters here. So I do the for loop and continue to, especially in the case of period asterisk case, I extend Si until the end. So it takes O of S time. So I can say the content of the recursive function in line 53, this takes O of S time. Yeah. In the worst case. So in total, it should take SB times S, length of S. So it should be S squared P. Yeah, but still this is acceptable because length of S is, lengths of S and P are less than 20 or equal. So this is completely acceptable. And for space complexity, I have to, I need the cache, which should store SP values. Yeah. And yeah. Also, I need the recursion stack. So in the worst case, does it take? So I move Si and Pi one by one. Yeah. And in the end, it takes S plus P. Yeah. As the depth of the recursion. Okay. Yeah, this is it. So probably this should be O of SP time complexity. Let me, modify this after implementation if something goes wrong with space complexity. Okay, now I start the implementation. So So yeah, I record this. And as the base case, first I can say if SI and PI ends exactly at the same time, I can say they merge. So this is a case when something like this. Or, no, sorry, or I can say if they don't merge at the same time, so here in this case, SI matches, SI ends first, but PI is still not ended. It's pointing to the last character. In that case, I should return false. Or if SI is not ended, but PI is, the SI is ended, but PI is not ended. In that case, I should return false. But this isn't correct. I actually, made this mistake yesterday. So I know that this is tricky. So let's say SI is ended, but PI has something. And let's say I have something asterisk. In that case, I have an option that this period asterisk that represents empty character. Yeah. So even though PI was not ended here, in the end, they match because this asterisk period can represent empty character. So I have to be careful about this base case. But at least I can say if SI is not ended, but PI is ended, I can say that's a base case to be returned false. So I write it first. Yep, that's case. So because I've already covered the case when PI and SI end at the same time. So if PI ends first, which means that PI is ended, SI is not ended. That's not good. Okay. So as I said, if SI is ended but PI is not ended, I don't take it as the base case and I continue. Yeah. So number one, here, I will check these 4 cases. So number one, A asterisk case or B asterisk case. So I have to take care that P index PI. Oh, it's been 30 minutes. So index PI. So I'm thinking of the case when there is asterisk next. So PI has to be taken to last index or before. And this case. So I think actually I can merge this A asterisk and period asterisk case. Let me tell you how I can do that. In this case, so char to be repeated should be self.s index si. No. I have to take a p. So this is a char to be, repeated. So let's say the first case repeats 0 times. In this case, the result should be, I have to move pi to pi plus 2 because I've consumed asterisk, some character and pair asterisk. So it should be much. Si is not moved, but pi should be moved by 2. Yeah. So if this is true, I return true from the method. Okay. Here, repeat char 1 times or more. Yeah. So how I can do this case? So I have to confirm if I repeat this character, this character has to match the character in string S when extending moving the SI index, just like I've explained here. So I move, okay, the first case, if I have only A asterisk matches asterisk character is repeated only once, SI should be here. But in that case, I have to confirm this SI char is equal to this A. In that case, I can do that. And if Si plus 1 char is equal to Pi char, I can repeat A twice. It's okay. 3 times this is okay. But 4 times, this doesn't work because C is not A, which should be repeated. So I move this Si until Si char is equal to the A in this case. And for each, I call the recursion. But if Si char is not Pi, I break. Okay. So repeat and index. Repeat and S index. This can be Si plus 1 or until the end character. And the ending, if let's say S and index. In this case, I break. Otherwise, yes, it's possible that I repeat char asterisk until this index. So what I have to check is f.match S and index plus 1 and start pi plus 2. Yeah, this child case. And if this is true, I return true. Otherwise, I continue. Okay, so now I've covered this case in line 110. Okay. So here, what I found is I confirm the something. Oh, no. There is a case that this char is period. Yeah. In that case, I can think that any character match. So I can say if char is not asterisk, no, period, and yeah, char is not as an index char, I can say they don't match. So I break. Okay, so now I take a look at the next case. But yeah, here I can say something. So at this moment, if they're not ended, sorry, pi is not ended, this means that it has something like this. Maybe it can be like this, or maybe just BC, AC. Anyway, I can say this pi character is not repeatable, which means that at least, I mean, exact this character A or maybe asterisk, which signifies a single character from A to Z, exists here. So what I want to say is, after checking this, something asterisk case, if pi is not ended, I should immediately return false. No, sorry. No. Yeah, I think so. Wait. pi is a good. No, yeah. If pi is not ended, but si is ended, I should return false. I do this here. Okay. So this is something like, yeah, obviously, this case. Like this. Okay. Let me quickly copy paste this. Si is ended, but pi is not ended here. Okay, good. So I think about the cases. Let's say this is period only. I mean, if so at this moment, pi is not ended, because if pi is ended, it already false is already returning line 102. I can safely say self.p at index pi. If this is period, what I can do is I just move pi and si. And if this is true, I can return true from this method. And here, so I compare self.s, si, and self.ppi. And if they're not the same, I return false. And here I can say, or I should say, otherwise, I will check. I call the match method with sorry, a bit confusing. If SSI is equal to self to PPI, if they're the same, it was checking the continuous result. And if they match, I return true here. And here I can say SI char is on PI char and PI char is not period. So I can return false. They don't match. Okay. So yeah, I think this is good. Maybe one thing I can change a little bit is maybe I can merge this line 133 and 138 like this. Okay. Good. So for this question, let me skip the dry run. Yeah. I'm not too energized to do that in this question. But basically, if I do the, dry run, definitely I will check this one maybe. I will quickly write the test case. So S and P, definitely I will check this case. First, for this should match nothing. Yeah. So in this way, I could check the case. I mean, when period asterisk represent empty character, and I can use period here to see if it matches a single character, and then I will check another one here, which represent C sharp 3. No, I will do this. Here, let me do this. In this case, I want to test that CC matches 3C, not 4C. Yeah. But C asterisk matches 3C, and the rust C matches with the actual C. Okay, I do dry run with this, but let me skip it and submit my code. Oh, accepted. Submit. Okay, let me check. So in this case, AAB and C asterisk A asterisk B. So this C asterisk should be ignored. And I want this A asterisk to match AA and B matching. I'm wondering if I really included the case that something asterisk should be ignored. I have it here. So it seems like, yes, I do. So let me check with which argument this register method is called. No. Wrong answer, use test case, submit. This case, 00 is tested and 02 is tested, yes, as expected. 02, yeah. And 04, I'm not interested in it. Wait, so seems like if I start from 02, it didn't match. So maybe I can just forget this C asterisk and try it. Yeah, it still fails. Maybe I can delete B and B. Let me check. Oh, in this case, B, this worked. So something goes wrong with this B, maybe? I don't know. So this A asterisk should match two A's. But actually, it takes 0, 0, yes, and 0, 2, yeah, and 2, 2. Okay. Wait, if I compare 2, 2, they should match because it corresponds to this case. PPI self.ssi is equal to self.ppi. So definitely it should reach here. Let me check. But not reached. In the case of 2, 2, no, sorry. Here in line 140, this should be equal. Yeah. Now I got assertion error. What's the problem here? Okay, let me print it out. So it fails at index 0, 0. It AA. Yeah, it's weird because if 0, 0, I see. I should return false here because I don't use else if here. I will take this block as the single case and return in the end. Yeah, I mean, I will take this. I take this line 144 to 47 as a big array return. Okay. Now let me submit. No, wrong answer again. What's the problem with this? This is true, but actually not. Sorry, expected true, but actually returned false. So this I is something I don't need. Yeah, maybe I couldn't cover the case that, I mean, this S asterisk should match until this S, but not until this S. But maybe I took care of the case when SSI is, covered by S asterisk. Yeah. So I'm specifically talking about this rhyme 131. So I want to see what this SI and PI is called with. So this I is index 0, 1, 2, 3, 4, 5, 6, 7. And this asterisk is 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so I really want to avoid the case that it is called with 8 and 7. Oh, actually not code with 8 and 7. Hmm. Maybe let me simplify the test case. I delete first 3. What did I do? No, I delete first 2 characters. Still fails. Let's say I delete the last character here. Still fails. And let's say I'll delete these 2 last piece. Now it passed. The problem is in the last PB and P asterisk. I will try to delete SS and S asterisk. Still fails, good. Let's delete IAS and IS asterisk. Yep. So it's almost there, I think. In this case, P asterisk should match with P asterisk should be taken as the empty string and it should end. But S is still in the middle. So it calls 0, 0, then 0, 2. Yep. In the case of 0, 2, it should return false. And for 2, 2, I don't know why it reached 2, 2. Maybe I find the reason. So S and index begin from SI, not SI plus 1, because obviously in this case, this P asterisk, I have to check. Okay, what do we say? So SI should be here and PI should be here. And I check this P asterisk corresponds to this I first, then enter P, next second P. So I have to check this exact SI first. So yeah, as I modified already, this should not be SI plus 1, but SI. Good. Okay. Now let me submit. Okay, finally accepted. Good. So let me quickly wrap up. So today I solved the question, regular expression matching. So in this question, I'm given 2 strings. The first one is string S, and the second one is pattern P. The P is the regex pattern, which includes A to Z lowercase characters, or period, or asterisk. And as the ordinary regex, period suggests a single character. Asterisk suggests I can repeat the previous character any number of times. And for this question, I use the top-down DP. So yeah, the interface of the recursion should look like this. So I check, the substring, which begins from index si, and substring, which begins from index pi. I compare these, and if they do match, I return true. If not, I return false. So with this recursive function, I could implement this question. Yeah. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.